Hello and welcome to this lesson on using Spring as a dependency injection container. First, let's try to define what Spring is. Spring is a vast and wide framework with lots of capabilities, so very difficult to define in one line what Spring is. However, we can try to kind of characterize it as Spring is essentially two things. At the heart of it, at its bare minimum, Spring is an inversion of control or a dependency injection container. Whatever that term means, even if that term is completely new to you, so be it. In a minute, we will see what that means. In addition to being an inversion of control or a dependency injection container, these two terms, inversion of control and dependency injection, you can use them interchangeably. So from now on, I'll use dependency injection, which is a more recent term, and inversion of control is the older, more archaic legacy term. So in addition to being this dependency injection container, Spring also provides us with a set of utilities which make it easy to use other Java technologies. By other Java technologies, I mean other Java APIs, maybe JDBC, maybe ORM like Hibernate or aspect-oriented programming, or transaction management, and various other technologies, could be messaging and others as well. So Spring is a whole bunch of utilities as well. As we said, at the heart of it, Spring is a DI container. Let's try and understand what this DI is all about. This IOC or DI is all about object dependencies. What do we mean by dependencies? By dependencies, we nothing but mean the other objects or the collaborator objects that our classes or objects depend on. For example, in a previous lecture, we saw that when we use a layered application, the UI layer uses classes from service layer. So service layer objects are dependencies of the UI layer. And service layer in turn uses the objects from data access layer. So data access layer objects are the dependencies of the service layer, and so on. So it's all about these dependencies. In the traditional application design, we got hold of the dependencies typically through direct instantiation or asking a factory method, or in older legacy J2EE applications, we would have done something called as a JNDI lookup. So we will not be getting into details of what that is. Let's just say direct instantiation, as we are doing right now. So one layer is directly using new operator to instantiate an object from the other layer. What could potentially be the problem with it? Well, as we have already seen, when you have to instantiate directly using new operator, you cannot do new on an interface. You will have to do new on a concrete class, which means a class in one layer will develop tight coupling with concrete classes in another layer, because it is explicitly naming and instantiating a concrete class from another layer. So if you wanted to replace a class in one layer with another class which will be developed in future, then you also need to change the code in the consuming layer. That's the problem that we are trying to solve. So this is the traditional pull approach, where the consumer pulls the dependency somehow. On the other hand, in inversion of control or dependency injection, there will be this push approach, which means something outside of the object pushes its dependencies into it. So we will not be doing new. We will not be directly instantiating the object. Instead, we will provide a mechanism or a facility for something outside of code to push the object. Maybe we'll design a setter method to push the object in, or we'll design a constructor to push the object in. And our object has no knowledge of which is the concrete class or how it gets its dependencies. It just assumes that somebody will push the dependency and give it the dependency. This push approach is what is known as this dependency injection. So as we've already seen with this diagram, we'll have these application layers. So what we want is, we want something to create an object of data access layer and to push it into service layer, and to create an object of a class from service layer and to push it into an object of UI layer. So we want something outside of our code that is nothing but the Spring framework, to create an object of data access layer class, to create an object of service layer class. We want Spring to create an object of this UI layer class. Not only we want Spring to create objects of these classes, because objects need to be created of concrete classes, and we don't want to hard code concrete classes in our code. So we want Spring to create objects of these concrete classes, and then we want Spring to push an object of a concrete class of data access layer into an object of service layer, and take the service layer object and push it into UI layer. This pushing is not what is known as dependency injection. In Spring terminology, we would say that the DAO object needs to be injected into service layer, and the service layer object needs to be injected into UI layer, and so on and so forth. So this is what we'd like to achieve. So the kind of changes that we may need to make to code, this is the pull example. So in the current design, what we are doing is this service layer class is by itself instantiating a data access object by invoking a factory method. In our code, probably we are doing new rather than factory. In push-based approach, which is the next example, so you see the same service layer class has an instance variable of the interface of the DAO. It isn't doing equal to new. It is not doing equal to some factory method invocation. Instead, it is supplying a setter method using which the framework or the outside world can inject the dependency into it. So Spring is nothing but a framework that can inject dependencies into our object. So that's what we're going to do next. So why is this dependency injection better? Well, two main reasons. It improves loose coupling and it improves testability. Loose coupling is improved because you don't hard code or you don't hardwire the dependencies between different modules. Instead, we kind of configure them outside of the code. This makes it easy to swap in a new implementation of some interface and swap out some existing implementation. Testability is improved because your objects don't care in what environment they are, as long as somebody injects the dependency. In fact, your objects don't even care who injects dependencies, whether it's the Spring framework or whether it's a test case. So as long as somebody injects the dependencies, your objects are happy. So these are the two main reasons why we would use dependency injection. So Spring is a framework that does dependency injection for us. So to understand the workings of Spring, we'll have to start getting used to some terminology of Spring. So in Spring, there is this term called bean. To understand this term called bean, we have to understand that in Spring-based applications, since our application code does not want to hard code the new operations because we don't want to hard code the concrete class names, so somebody should create objects, and that somebody is nothing but Spring Framework. So in Spring Framework, there is a name for such objects that Spring Framework creates, and it is called a Spring Bean. So in Spring, a Spring Bean is an object. It's an instance. Don't look at it as a class. Look at it as an instance or an object that is created and managed by the Spring container. So Spring Bean is an object that is instantiated and managed by the container. So somehow we have to tell Spring which objects to instantiate and how to assemble the application together. So this Spring container or the Spring framework gets its instructions on which objects to instantiate, configure, and assemble by reading configuration metadata. So the configuration metadata to a Spring-based application can be supplied in three different formats, either in the form of XML or Java annotations or Java code. We can mix and match all these three formats. Of these three formats, XML is the oldest and currently considered legacy way of supplying configuration metadata. We will not be using them. We will be using Java code and Java annotations. So somehow we will have to supply this configuration metadata to Spring, and Spring, based on this configuration metadata, will instantiate the concrete classes, and not only instantiate, this configuration metadata will also help Spring to configure and assemble all these beans as well. So once we have supplied this configuration metadata, we'll have to somehow create an object of this class called application context. So in Spring, an object of this application context represents the Spring container, and this application context object is the one which is responsible for instantiating all the beans, for configuring them, and for doing all the dependency injection and assembling all of the beans. So that's what is Spring as a DI container. Next, let's see how to actually go about using Java configuration to do dependency injection.